Hi, welcome back. So in this video, we are going to analyze how to compare two populations assuming independent sampling using t-student test. So first of all, let us start with the problem. So there are data on the number of scores for two football players. We assume that the games were different, so we do not have to assume that data were collected for the same matches. And we have to analyze whether two football players have the same average scores. Or in other words, we have to analyze whether difference between the average scores of the first player and the second player is equal to 0. And we will assume that alpha is equal to 0.1. First of all, let us compute test statistic. It's going to be more complicated than before, but we will figure this out. So we are going to need information about the sample mean and sample standard deviation for both samples, which means for the first football player and for the second football player. So first of all, let us compute the weighted average standard deviation value. So this is the formula. We have 9 observations for both players, so N1 and N2 are equal to 9. Here we have standard deviation for the first player, standard deviation for the second player, and we simply compute this value. Keeping this in mind, we can actually proceed to calculating t statistic. So x1 bar is equal to 1.33, so this is average score of the first player. X2 bar is equal to 2, so this is the average score of the second player. We want to investigate whether the difference between those average scores is equal to 0. That's why d0 is equal to 0. And as a result, the t-value we obtained is equal to negative 0.27. Consequently, we can go for the critical value. So we have 9 observations in each sample. In total, we've got 18. And when we subtract 2, we get 16 degrees of freedom. Because we are performing two-tailed test, we have to split alpha, which value is 0.1 by half. So this is the value we are interested in, and the critical value is equal to 1.746. So we've got two rejection regions, everything to the right from 1.746 will be in the rejection region, and everything to the left from the negative 1.746 will be in the rejection region. And as we can see, our value does not go within any of those rejection regions. In other words, we have to conclude that we cannot reject the null hypothesis, which states that the difference between the average scores of two football players is equal to 0. Okay, actually, you can also use Gretel for this purpose. So let us go back to the information about means and standard deviations. So we will choose Tools, Test Statistic Calculator, and here we are analyzing two means. So in the first sample, average number of goals is 1.33, standard deviation is 1, size of sample 9. In the second sample, we have 2 as the mean, approximately 745 as standard deviation, and we also have 9 observations. And we assume the difference in means is equal to 0. So we have to click OK. So first of all, give me a second. Yeah, that's better. So first of all, Gretel will provide you with the distribution. So as you can see, this is our actual t-statistic value. And, just by analyzing it visually, it definitely does not go within the rejection region. We can also analyze the formal statistic. which is here. So the null hypothesis states that difference in means is equal to 0. Our test statistic is negative 26.74 or negative 0.27 as we calculated, which is the same, yeah, we just rounded a bit. And for two-tailed test, p-value is close to 80%, and for one-tailed test, it's close to 40%. So as you can see, we did everything correctly, and we indeed cannot reject the hypothesis that two football players have the same average score. Yes, so thank you. That was it when it comes to two-tailed test. And in the next video, we are going to discuss one-tailed test. Thank you for watching.